Thanks, Luke, and thanks for having us on the show. So over about the last 2 months, we've actually done two things with artificial intelligence. First, at HHS, we spend about $17 billion a year in professional services expenditures. So the first thing that we did is we took GAO reports on what determines if a contract's inherently governmental or not. And we used that as a framework to analyze our professional services expenditures. We actually read through about 9,000 statements of work using natural language processing. We indexed every word with a number in those statements of work. We created a vector, pushed it into a predictive model, and then came up with a confidence score as to whether or not the statement of work being performed was could be inherently governmental or not. We then took it a step further and actually read through labor categories, personnel descriptions, and job descriptions in this pilot, and we connected them together. As you know, the hardest thing in analyzing pricing for professional services is understanding apples-to-apples comparisons. So by doing that, we've actually taken labor categories, anchored them to PDs for government positions, and now we have a string where we can look at the cost of a government employee, the cost of a professional service provided by Company A, and a cost of professional service provided by Company B. So we did that over about a 6-week period. It's a proof of concept. We think with an 86% confidence score that we've identified around $111 million in savings, and we're not forcing that decision on the workforce. What we're trying to do is share that information with the workforce and then use their feedback to kind of fine-tune our model. So it's the beginning of a deep learning capability. We built it in-house. We didn't use an existing product. We felt that it was cheaper to test it in that way. Mm-hmm. And then if we went to scale it on an enterprise level, we would look for products in the marketplace that could scale at an enterprise level. The second thing that we did over the last couple of weeks, and we did this at zero cost through an existing ELA, is we looked at our TIC, our Trusted Internet Connection, and we said, geez, it would be great if we could analyze everything hitting our TIC in real time, which is structured data, leveraging a neural network. We used a recurrent neural network on the professional services stuff. We're using a neural network on the TIC data because it's structured in nature. And so with a very quick proof, what we've been able to do is take the data that hits our TIC and what happens over a 24-hour period, we can analyze in a matter of seconds. And we used to do it with an analyst, and it would take 4 to 5 days. And the idea is that we can then use what we've learned from the recurrent neural network, and we can extend that to unstructured data sets that we have from a cybersecurity perspective, and we can start to create characterization around threat information, around the structured data that actually hits our TIC. So those are kind of the two proofs that we have going on. We're pretty excited about them.
It's incredible.